Casting. In this video, we will learn what it means and how to cast values. Okay. Consider the following program. Much of it is code you've seen before. We're simply declaring an integer and a double and assigning it a value before printing it out. However, the only difference here is that on the left side of each value is a type written inside a pair of parentheses. These are examples of cast operators. Cast operators temporarily converts the value from one type to another type. So what you see in the third line is a value that's originally a double, 5.8, being casted to an int, temporarily converted to an int. Then on the next line, you see a value that's originally an integer, 10, being casted from an integer to a double. Thus, when x and y get printed out, our output is 5 and 10.0. Now, why did we get those values? Well, because firstly, when a double is cast to an integer, it gets truncated or rounded down. Hence, 5.8 got rounded down to 5 before getting stored inside the variable x. Secondly, when an integer is cast to a double, it receives a decimal point. So the value that was originally 10, a plain integer, received a decimal point to become 10.0 before getting stored inside the variable y. Now consider the following print statement. Inside this print statement is an arithmetic expression, which you are familiar with by now. However, there's also a cast operator inside of it, an int cast operator. The question is, what does that cast operator apply to? Does it apply to the 5.8? Does it apply to 3.5? Or does it apply to both? Well, the rule is as follows. Cast operators apply only to the operand that immediately comes after it. Henceforth, the int cast operator in this example only applies to 5.8. It must also be noted that cast operators take precedence over arithmetic operators like plus, minus, multiplication, so on and so forth. Thus, before we do any addition, we must first cast 5.8. As mentioned earlier, whenever you cast a double to an integer, the value gets truncated, so 5.8 becomes 5. Now that the value has been casted, we can now move forward with the addition. 5 plus 3.5 gives us 8.5, thus 8.5 gets printed to the screen. Now consider this print example. We're using the same values as before, but now instead of casting 5.8 to an integer, we're casting 3.5 to an integer. As mentioned earlier, casting takes precedence over addition, so before we add anything, we must first cast 3.5 to an integer. Whenever you cast a double to an integer, it gets truncated, thus 3.5 becomes 3. Now that the cast has been performed, we can now do the addition. 5.8 plus 3 gives us 8.8, thus 8.8 gets printed to the screen. Now consider this print statement. We already mentioned earlier how cast operators take precedence over arithmetic operators. Well, parentheses takes precedence over cast operators. So before we can do any casting, we must first evaluate this expression inside the parentheses. What's 5.8 plus 3.5? 9.3. Now that the parenthesized expression has been evaluated, we can now apply casting. 9.3 casted to an integer gives us 9, thus 9 gets printed to the screen. Now consider the following line of code. Okay. Here we're casting the integer 5 to a double before assigning it to a double variable. Thus x will store the value 5.0 when all said and done. However, using the double cast operator in this example was unnecessary because whenever an integer is assigned to a double variable, Java already automatically casts the integer to a double. So we could have simply assigned 5 to the double without using the operator and achieved the same result. Likewise, we could have simply assigned 5.0 and got the same result. In either case, when we print out these three variables, the same value gets stored either way. So, in summary, casting from an integer to a double rarely happens because Java already does it automatically. An important point must be made about truncating. When a value is rounded, it becomes whichever whole number is closest to it. So for example, 9.7 if rounded would round up to 10 because it's closer to 10. However, 9.2 when rounded would become 9 because it's closer to 9. When the value is truncated, however, we round down, always. Even if the value is 9.999, if you truncate it, it becomes 9. That all being said, we'll close this video off by showing how truncation can be used to round a value in Java. Suppose I declare a double and set it equal to 9.3, and I want to round that value. The first step would be to add 0.5 to that value. Thus, D would become 9.8. The second step would be to truncate that value, which we can do by casting it to an integer. Thus, after we cast it and we print out the result, you see we get 9, which is the correct rounded value of 9.3. Let's repeat these steps on 5.8. Once again, step 1, add 0.5. Thus, D will become 6.3. The next step, truncate it, which we do by casting it to an integer. When we cast 6.3 to an integer, it becomes 6. Thus, when we print out x, 6 is our output.